Those of you who watched my road trip video will know that I set out on that trip to pick up a Pylontech battery and battery inverter that I bought on eBay. Unfortunately, when I picked up the equipment, I found that the Pylontech battery didn't switch on. I mean, it was completely dead. There were no lights or anything. So, can it be revived? Okay, so here's the unit that I got, and you can see I power it on, nothing. So it's completely dead. So I'm not sure that I can bring it back from charging through these because the BMS will be unpowered. I don't know whether this will allow me to get charge into the battery. So I might have to open it up and charge the cells slowly using a normal charger and bring them up enough that I can get the unit to power up, and then I can maybe charge it up in the normal ways. I'm going to open it up and try and charge the cells individually or see if they've all swollen up from being fully discharged. So let's have a look and see what the situation is. There we go. Well, the packs don't look swollen. There's a bit of a ridge in that one. So let's test the voltages of the individual cells as they stand at the moment. Negative, so we want to get that off. That's an XT90, I think, connector. I've got some of those lying around. Okay. I'll tell you what, let's get that one in first. Okay, so it's 18.3 volts, which is not good. So I need to try and pull that up a little bit. Okay, so now I can get to the actual, actually I can't because this BMS board is right in the way. But initially, let's have a look what we can do with this. Okay, so I'll take it right down to 1 amp. Lithium iron phosphate. So let's see. Charge 1 amp 5S. Lithium iron phosphate. Okay, it's coming up. Okay, there's not a lot more we can do now. I mean, that should... these smart chargers are pretty clever, so it knows that this battery is well under voltage, so it's limiting the charge current to 0.2 amps until the voltage comes up to where it should be for the bottom of the pack. So once this gets to about, I think it'll be about 12.5, 13 volts, then it should then go up to the 1 amp that I set it at, and hopefully then that will bring this pack up slowly enough that it won't make it swell up, but we'll find out, I guess. And then it'll be, even if it does come up, it'll be a question of how much of the cells become damaged. So how much capacity will they still have? Because they could come back up, but they could be damaged permanently. But potentially, if there's a few good ones in there still, I can use them to fix my other pack and get that one back in service. But hopefully I can get them up and they'll all be okay. The good thing about lithium iron phosphate is it does let you discharge it quite low down, but we'll see. Okay, well, it is rising slowly, but this is going to take a long time, so we'll come back to this in a while and see how it's getting on. So we've hit about 13 volts, and then it ramped up to the 1 amp. So it obviously thinks that it's now at a high enough voltage for it to charge normally, which is a good sign. So what I'm going to do is leave this charging at 1 amp, and I'll get it to its mid voltage, about 3.2 volts. And then I'll do each of the 3 packs like that, and then I'll leave them to sit at 3.2 volts for a few days and see if they hold the charge at 3.2. And as long as they hold the charge, I think that's a pretty good sign. And then what I'll do is I'll reconnect the board and try and charge it normally and see how we get on from that, or at least see if the unit will power up properly when all of the packs are at 3.2 volts, so per cell. So yeah, I'll leave this going until it gets to 3.2, and then I'll put it on the next one and we'll carry on from there. Right, I got the first pack up to 15 volts, which is, you know, sufficient. So now I'm doing the second pack, and again it was very low voltage, about 6 volts. So it's coming up slowly. It's at 11.2 2 now. Once it gets to about 13 volts, then it ramps up. So I'll try and get this one to about 15 volts as well, and then I'm going to do the last one and leave that one going until the morning, and then at least they're all, you know, back into normal values. I'd rather get them all sort of into a normal values as sooner rather than later. So yeah, I'll get them all up to about 15 volts, and then from there I'll probably charge them up to the sort of mid voltage on all of them, and once they're all at about it'll be about 16 volts total for each pack, then I will connect it all back up and see if I can get the battery to power on, and then I might try charging it normally after that. Okay, I've got the balance leads connected now, so you can see the individual cells, and it's looking really positive. All of the cells have exactly the same voltage, and they seem to be coming up nicely. I got the 2 of the packs sort of up to a reasonable level, and then started on the 3rd one. And when I came down this morning, the 2 packs that I'd got up to a reasonable level had held that level overnight, so the voltage wasn't dropping away, which is also another good sign. So I'm feeling quite positive at the moment. I think this is probably going to be salvageable, which is obviously really good. But yeah, let's keep going. I want to get them all to about 16 volts. Each of the packs, and then I'll leave them for 24, 48 hours, something like that, to see if they all hold that voltage. And as long as they do, I will connect the BMS back up and see if the unit will switch on without any alarms or anything, which fingers crossed it will. Right, okay, the batteries are all charged now, all of them up to 3.21 volts per cell, and all the cells are at the same level, which is really good. So what I'm going to do now is leave them for a couple of days, and then I'll plug the balance leads back into my charger here and have a look after a few days and see if they're holding the voltage. I'd expect them to drop a tiny bit just due to temperature fluctuation and stuff, but basically as long as it's still close to 16 volts and they're all pretty much the same, I'd take that as a really, really positive sign. And then what I'll do is try and connect it all back together and try and turn it on and see what happens. Right, it's been 24 hours, so these cells were all at 3.2, so let's see if they've managed to hold their charge. I need to go that way. So 3.19, that's, you know, pretty close. I think that's certainly within the realms of being really good. So 3.19, that's that first one. Let's try the second one. They're all at 3.19 as well, so that's really good. Very promising so far. And then let's try the last one. Find it. And yeah, well, those two of them are on 3.19. The others are on 3.18, but that's probably again perfectly acceptable. I mean, there would have been some slight voltage drop as the battery settled after having been charged, so I think that's all pretty good. That's really good. So I think what I'm going to do now is charge it up to about 3.3 on each of them, and then I'm going to connect it all together and put it all back on and see if we can get it to power on properly. Okay, they're all now charged up to about 16.5 volts per pack, so that's about 3.3 volts per cell. And let me just stop that. And you could see just there that it took about 8 or so amp hours to raise it from 3.2 to 3.3. So that gives me a reasonable amount of confidence that these packs will still hold a good amount of charge, but we won't know that for sure until I do a proper test on a fully charged pack. But as these are all now the same voltage, just before I reconnect everything back up again and make it attempt to switch it on, I'm going to connect each of these in parallel and leave them for 24 hours to make sure that they're all exactly the same as each other before I connect it back together, and then that way the whole thing will be properly balanced. So I've just used these crocodile leads to connect all the positives together and all the negatives together, and then I'll leave that for 24 hours now, just so that they can properly even out, and then I'll just check the individual cell voltages one last time once that's complete, before I then connect it all back up, screw it all back together, and see if it will switch on. Right, it's been sat for 24 hours now, so I'm just going to have a quick last look and see if all the cells are at the same voltage. What's that? 3.38. On that one. That's the first one. Look at the second one. They're all at 3.28 as well. And the last one. They're at 3.28 as well. So that's really good. Everything's in balance. So what I'm going to do now is connect it all back together and see if it will power on. Okay, it's all good. I'll just connect this one up and then let's see what happens.
Ready? Well, we've got a light, which we didn't have before. Okay, so we've got a fault.